Okay, welcome everybody. This is Getting Started with IBM SPSS Statistics. My name is Jonathan Quinn. I'm just going to wait for a moment as the participants are joining. So just bear with us for a moment. Okay, I think that's long enough. Welcome to Getting Started with IBM SPSS Statistics. This is a webinar that Smart Vision Europe run on a fairly regular basis. We run a number of webinars throughout the year, which you may be aware of, and we're running 3 today. So we have Getting Started with IBM SPSS Statistics, we have data cleaning of IBM SPSS Statistics, and we have significance testing and how to interpret significance tests. My name's Jonathan Quinn. I'm an analytics consultant, and I've been using SPSS for a very long time. I'm joined online today by my colleague, Rachel Clinton. Rachel will be just monitoring the chat as we're going along. For those of you who haven't joined any of these sessions in the past, you should be aware that these sessions are recorded. So this one's going to be recorded. That's good. So you can listen to it again. And there's a little bit of slideware. So we normally email out a link for you to download those materials after the session's ended. If you think the session's particularly relevant for colleagues who are unable to join today, and you can get enough of them together to maybe justify a private session, then by all means, just ask us, just drop us an email or give us a call, and we'll see if that can be done. And with regard to asking questions, all the lines are muted. So we ask you to use the chat panel. If we run out of time, of course, we'll follow up with you afterwards. Normally, we would answer the questions after the session's ended, and we send an email out of any specific questions that people have. Okay, so if you don't know who Smart Vision are, we are a technology organization. We're an accredited partner to IBM, hence being able to provide SPSS statistics and talk about that. Also a company called Predictive Solutions, and also Data Robot. And we specialize in advanced analytics, statistics, big data technologies, machine learning, data science, all that type of stuff. But we do also work with open source technologies such as R and Python and Spark. And we're a relatively small organization, but we're made up of a team of veterans from the analytics and statistical software industry. So we all have about 15 to 30 years of working in there. The common denominator is that we all met and worked together at some point for SPSS Incorporated prior to the IBM acquisition. So I worked for SPSS for about 16 years and IBM as well, and then worked for SAS, if you're aware of who the SAS Institute are, who also provide statistical software. And that means we've got very deep experience of applying analytics across many different applications in many different vertical sectors, including things like retail and gaming and water utilities and power utilities and telecommunications and banking and finance and central government and local government, etc., etc. So we're very well placed to talk about how this type of technology is used and to talk about best practice, really, with regard to using it. And today, of course, we're talking about this classic piece of software, which is SPSS Statistics. SPSS Statistics is one of the most widely used statistical or analytical platforms in the world. So we'll give you a little overview of that. Then what I'm going to do is start a demonstration, and we'll demonstrate how to get data into the system, how to format it and get it in shape, and then a couple of sort of procedures around working with data, such as creating new fields. You're creating something like a banded field, like age group from age, creating filters in the data. So you're selecting a subset. Then we're going to look at using publication tables, or creating publication tables using the tables module to create different types of publication quality reports. We'll also touch on some basic significance testing and how to apply that, say, to a chi-square test. And also, hopefully, if we've got a bit of time, we'll look at a little bit of syntax and look at creating charts in SPSS Statistics. So the idea is to give you kind of full, rounded A to Z sort of guide through the software within a relatively short period of time. So first of all, let's talk about SPSS Statistics. So the This is actually an unusual piece of software because it's been around since 1968. And it's one of the world's most popular data analysis and statistical interrogation platforms. It's very difficult to talk about a typical user of SPSS. People often do. You'll see people talking about that on the internet and say, oh, this is used by marketing people, or this is used by social scientists. But as somebody who's worked with the organization for a very long time and worked with SPSS users, of course, what we know is that there isn't really a typical user, in the same way that there isn't really a typical user of Excel. It's everything from people doing epidemiology to carrying out market research, survey research, or business reporting, to things like direct marketing or credit risk applications in finance, or process modeling and asset management and predictive maintenance. There's a very, very wide variety of different applications. Now, in the basic copy of the software, we'll talk about what we mean by the base software in a moment. The sorts of things you would expect to see are things like crosstabs, frequencies, descriptive statistics, lots of statistical tests like t-test and ANOVA and chi-square and correlation, and prediction for numerical outcomes like linear regression, as well as things like factor analysis and cluster analysis. These would all be in the standard basic copy of SPSS Statistics. And the reason I point that out is because SPSS comes with a number of add-on modules. These days, IBM tends to sell SPSS in packs, so the predefined packs of modules. So there's SPSS Professional, there's SPSS Premium, that type of stuff. But SPSS Base, as I say, actually has quite a lot of functionality in it. These additional modules only appear as extra dialog boxes. It's not always clear to people whether or not they've actually got an additional module installed. There are certain ways in which you can find that out, in which case you should check out our website to find out how to detect what modules you have installed. But to give you an example of that, if we look at an example like a decision trees module, decision trees module appears simply as an additional dialog box here. And it allows people to build predictive models and create profiles of customers, employees, and find key behavioral segments. And they're very popular decision trees because they represent predictive models visually, and they're relatively easy to understand compared to like a lot of classical statistical models. This would be an example of a decision tree output, which looks like a sort of family tree and tells you what are the factors that drive a particular outcome. In this case, the outcome is whether or not people survived on the Titanic, and it tells us that the most important factor was gender, whether or not they're male or female, and then if they're male, what their age is and what class they were traveling in, and it tells us what the expected survival rate would be for those. So that type of approach has a lot of different applications and used across many different industries. And it's an example of why somebody would have a module, a particular specific module in SPSS Statistics. If you wanted an overview of all of the different modules and what they all do, then a good guide is to go on to our website, and we have little short video guides, less than 2-3 minutes, that type of thing, that just give you kind of overview. So if you're vaguely aware of these modules, you wonder what's in data preparation, what's in exact tests, what's in neural networks, what's in complex samples, then this is probably the easiest place to find that out efficiently. Okay, before we start doing a demonstration, whenever we teach or whenever we give training courses on SPSS, we're very aware of what type of level of skills that people need to acquire to have a basic proficiency with the system. And in fact, this basic proficiency could be applied to almost any statistical software, any analytical software. Same would be true of R, or same would be true of something like Stata or something like that, or even applications that do business reporting, such as Tableau. And the most important areas are that you should be able to read in data, and you should be able to format it in some way, because obviously that's pretty important. And the second thing is you should be able to manipulate it and transform it in some way. So you should be able to calculate the ratio of one field to another, or calculate the lapsed months between two dates, or to take a variable and to band it into groups, that type of thing. And the last thing is you should be able to analyze and do something with the results, send them a copy and paste them somewhere, or export them in some way. So those are the three broad areas, and those are the three areas we're going to focus on today. So let's have a quick look. I've literally just installed a new copy of SPSS. This is just the latest edition of SPSS. I think it's just come out last week, I think. And this is SPSS version 29. It's SPSS version 29. So most of you won't have this installed, but if you have an earlier version, don't worry about it. It's going to look very, very similar. It's very hard. It's kind of a subtle difference between one version and the next. So when you open up SPSS, you're going to get this sheet that looks a bit like a spreadsheet. And I would say that that's one of the areas where people get confused and pretty early on and get frustrated, because if you start to think of this as like a spreadsheet, it's not a very good analogy. It's not a very good way to think of it. This is just a data editor. This just shows us a data file and allows us to, see the columns, interact with the columns and the rows, and to change the values. But there's no sense that it's a spreadsheet in the sense that you could create a table down here and you could put a formula up in there. So don't think of it like Excel. It's just a window where we can see data. SPSS has a habit of generating multiple windows. So one of the things you might be aware of when you first install it is that you can have more than one data file open at the same time. And that can be a bit confusing for people. So just be aware of that. You can switch that off. You can go to Edit, Options, and you switch on Open only one data set at a time. That's probably if you're just starting from scratch, it's probably a good tip to use, because it does get confusing when you've got multiple data sets open at the same time. The second thing that SPSS does is it generates an output window. So whenever you do some analysis, it puts the results of that analysis onto an output window. So another window opens up. And then there are other types of windows, like syntax windows, where you can turn your commands into literal syntax, into code that you can type in or paste in SPSS, so that you can automate a lot of your procedures. We're going to begin here just by opening a data file. And obviously, the data file that's most appropriate to open is one which isn't an SPSS file, because we're starting from scratch. Most people working with SPSS data, usually the data originates somewhere else. It might be on a survey platform like SurveyMonkey, or it may be on a reporting platform, or it may be a database, or it may be an Excel spreadsheet. Certainly things like CSV files and Excel files are the most common sorts of data formats that are read in the SPSS. So if I want to read in, let's say, an Excel file, there are various ways in which I can do it. I can go to File, Open Data, like I did here, and then have it look for an Excel file type. And you can do that. Another approach is just to go to File, Import Data. I'd probably recommend this approach: File, Import Data, Excel. So you can see all of the non-SPSS file types that you can read in there: CSV data, text data, Stata data, SAS data, that type of stuff. So we're going to go to Excel here. I'm going to read in a workbook file called employee workbook.xlsx, and then click Open. And what it does is it starts this little wizard for me, or it gives me this little window, and it basically says, okay, if you want me to read that in, I'll just read that in using the default settings. I could click on that. A couple of things to be aware of is I generally tend to switch on, or experiment with trying this, switching this on, if there are hidden spaces in string characters. Let's say there was a few rows here where it didn't just say F, but it said F space space. That can kind of sneak into some data, and it will treat that, anything which has a space on it, and versus something that doesn't have a space before or after, it'll treat them as if they're separate values. So if I did like a frequency table, it would look like there were two categories of F for female. So sometimes what that does is it just detects any spaces before string, character string. These are non-numeric variables, and just trims them off. I, generally speaking, tend to switch that on. So let's switch it on, see what happens. The other thing to bear in mind is that it tries to guess what type of data it is from each column. So in each column, it says, okay, if 95% of the values in that column are numbers, I'm going to make that a number field. And that means that if there was a single X in this column field here, it would, and I read it using this setting, I read it as a number, it would just make that a null value. It wouldn't read in the X. Whereas if I switch that off, it would say, no, I'm going to, don't base it on 95%, just base it on all the data, 100%, and try to format it based on all the data. So this is just a rough rule of thumb saying, look, if 95% of the values in a column are numbers, then I'm going to assume that that was meant to be a number column, and I'm going to read it as a number. And this is an issue with any sort of system that reads data, you know, that it's the system's always trying to make sense of the data and trying to think, well, what's that field meant to be? Is it meant to be a number? Is it meant to be a series of categories? It's trying to interpret that. It's the same for every system. So this is what SPSS is doing with an Excel file. So I click OK at that point. It will read that file in. The first thing we notice when we read it in is it's just raw values. Okay, so here we have a field called edduc. We don't really know what that is. And it's got a little symbol next to it. It's got decimal places, decimal 0. Here, job cat, we don't really know what that is. It's got, looks like it's got values 1, 2, 3, 4. And gender here looks like it's been squeezed together. That's because it had a width of 1. So all we got to do is just to see it, we just got to drag it out a little bit. So we just drag it like that, and we can see it. So the first thing we're dealing with here is the fact that we've read some data in. And now we're going to format it. But before we do so, let's look at one other example of reading a file in. I'm going to go File here, and I'm going to go Import Data. And this time I'm going to import a database, just so that you can compare and contrast the difference between importing an Excel file and a database. It'll look very similar. Data sets look very similar. I'll be able to close one of them. But here, a database, if I click New Query, it opens what's called the Database Wizard. And the Database Wizard is a little wizard that allows you to point to different databases that the system can detect. Okay, and how does the system detect it? It detects it using this facility here, which is called an Open Database Administrator dialog. That is something that exists in Windows. It's got nothing to do with SPSS. It's something that exists in Windows. So here I have in Windows, I've created a link. It's kind of like a link to a little database, which is access here, called employee access. There's another one here, which is actually a SQL Server link. I've created that outside of SPSS. So if that's created outside of SPSS, and then SPSS will be able to see it when you actually go to the database wizard. If you can't create it or you don't know how to do it, then normally what you do is you get your IT department to do that for you, to create that link for you. And very often you need the IT department to do it because the IT department won't necessarily allow people to create links to operational databases because, you know, they might want to control who has access to that. So in this case, it's just me clicking on the link and saying, okay, I can see that the employee access database is there. I click next at that point. It might show me lots of different tables because, of course, you might have different tables, one for the names and addresses of the employee, one for their work history, one for the salary, that type of stuff, one for their department details. In this case, it's just one table with lots of fields inside it. So I can just drag it across and then hit next. And it says, okay, do you want me to retrieve all the data? Because it might think it's a really, really big table. And I say, no, just read everything. It's all right. I don't need to randomly subsample them or retrieve them based upon an expression like people who have been employed in the last 6 months or something like that. Hit next. It tells me what the fields are going to look like. Hit next. It shows me what that query will look like as SQL. Well, I'm not really interested in SQL or query, so I just want to hit finish, and it reads that in. Okay, so now it's read in, and you can see it looks very similar. And look, we've now got 2 data sets open. So they're pretty identical. I can shut down either one of them, but I'll shut down the second one. I just need to click X and say, no, I don't want to save that. No, back. So that was just an example of an alternative to reading in a third-party system, a third-party data file, not an Excel file, but a database. That's how you would do that. Okay, let's look at this, trying to clean this file up so that we can do some analysis on it. I'm not going to do all of the data formatting here manually, but I'll show you some examples. So for example, if I click here on the variable gender and hit Descriptive Statistics, it actually shows me a little table. It squirts out a table onto a new window, which is the output viewer window. And I can shut that down, say I'm not interested in that anymore. But the key here is that I right click on it and I hit Descriptive Statistics. That is just a really simple way to get really quick results. It's just sort of quick and dirty summary. It's a little trick. Right click here. Look at this one for salary, Descriptive Statistics. And it gives me the mean salary, the median salary, minimum, maximum. And I can shut that down, so I don't want to keep that. But the key here is that with the variable gender, we have just the values F and M, okay? And just the word gender. We don't have sex of employee and female and male in there. So we might want to format this this data set, this column in a way that makes it a bit more pleasing with regard to the output. And one way to do that is to jump from this data view to what's called the variable view. The variable view is where we set each column up. It's where we control the variables and how they're labeled and what the legitimate values are. There are different ways to get there. You can see I can click here on the bottom tab, or I can double click on the header and it just jumps to it. So it just jumps to that particular column here. And now if I type in for what's called the variable label, I put in sex of employee, and I right click on this. It doesn't say gender anymore. It says sex of employee. Okay, so that's one piece of labeling. What about the values themselves? Don't they need labels? So they do. They're called value labels. So we go here and we tell it that the value M should have the label male attached to it. And then hit another one. What's the value F? Should have the label female attached to it. Click OK. And now it knows that when those values F and M occur, it should display them as using the value label. So if I right click here and do descriptive statistics again, now it says sex employee, female and male. There's something else here actually, which is that you might get values where something's missing. So you could say, okay, that value there is just missing. So I've just taken out that value male. What happens when I right click on that? Well, now it just says blank. There's one blank here. I could give it a special value and say, okay, X meaning unknown or unidentified at this stage. And that just means an X is going to appear. But if I go here and say, okay, I'm going to add X and say unknown, I can also do something called assigning a missing value. The missing value is very important. The missing value is saying X is unknown, X is missing, that data is missing. So don't include it in your analysis, don't include it in the percentaging. So if I right click and do descriptive statistics now, you can see it says female, male, and missing unknown one. So we get 2% columns here. So we have a percent column here showing me 45%, 45.7% female, 54.1% male. And then what's called the valid percent. The valid percent is if I take out the missing group, if I take out that one missing case, which is only 0.2%, then of the known values, it's 45.8% female and 54.2% male. This is important, of course, because you might get lots of values being read in. You might get values like, a value like 0 here, indicating that we don't know what that value is. You might get NAP for not applicable or something like that, in which case being able to tell SPSS what values represent missing data is kind of important, and that's what the missing column is for here. We can tell it what values represent missing data. Okay, I could continue working my way through this, continue to format the data. It wouldn't be very interesting for you to watch it. So I'll show you a quick way to format the data. If I've already done this once in the past, let's assume that this is a regular file that I extract on a monthly or quarterly basis from a database, let's say, or something like that. Then I can use a previously formatted file as a template. A previously formatted file as a template. So just another data file. And to do so, all I need to do is go to Data, copy data properties, and then search for that previously formatted file. And this SPSS data files are given the extension .sav, save, or salve. It turns out I've got a previously formatted file called employee, just the variables. It's literally doesn't contain any records in it, just contains a bunch of variables which have all been nicely formatted. If I click open on that and hit next, it will match that formatted variable, set of variables to these unformatted set of variables, and it will copy across the variable labels, the missing values, all of these other elements to that, which are called dictionary elements, which are things like value labels, custom attributes, formatting, all that type of stuff. Hit next and hit finish, and you immediately see that it suddenly formatted the data here. And we know it's formatted because we have this concept of value labels, and you can actually switch on or off the value labels as they are displayed in the data set here. Interestingly, the formatted data set did not have the variable gender formatted. I did that manually here, so it just ignored it. So the formatting on gender is just from what I did earlier, but everything else is formatted like job cat here. We didn't know what 3, or 1 stood for, 3, 2, or 1 stood for, but it actually stood for the job category. If I right click on that and hit descriptive statistics, we can see here is the job category: 76% clerical, 5.7% custodial, 17.7% manager. And the same here for minority. This is whether or not people are an ethnic minority. So this is a data set that was quite well known. It was used in a court case in Chicago in the 1980s. It was originally called the bank data set because they were bank employees. And it was used as part of an equal opportunities civil action that was taken against the bank. So hence, information about people's minority status, whether or not they're male or female, and the job category, as well as their current salary, their starting salary, how long they've worked in the job, what their previous experience is, how many years of education they have, etc., all used to kind of to indicate or used as statistical evidence to support a particular motion in a court case. Okay, so there we've read in our data file. We formatted our data file. What about analyzing the data? Well, you've seen there already that one of the things I can do is I can right click and I can ask it to give me some descriptive statistics. And what's interesting is that the type of output it creates here depends on the field type. So this is called a nominal field because it's categories, whereas this is a continuous or a scale field. It's just numbers. So if I right click on the scale field and say, give me descriptive statistics, it actually doesn't give me any percentages. It just gives me some summary statistics, and that's appropriate. Okay, that makes sense. So what's happening there is it's basically going to analyze descriptive statistics frequencies, and it's doing frequency tables. So I'll do a couple of frequency tables of these category variables here. I'm going to do minority, I'm going to do employment category here. And I'll ask for charts, and I can ask for, let's say, some bar charts or pie charts, something like that. I can also ask for summary statistics here if I so needed them. I don't really need them at this stage. So I click OK at that point. It creates two little frequency tables for me, and it gives me 2 pie charts at the back of that. So what's happening is you can see it's just constantly adding this stuff onto the output viewer window. So, and if I want to run any of these procedures twice, I could just go here and say, call that dialog box up again, just click OK, and it just runs it again. Just runs the procedure again, it just adds it onto the end. So knowing that I can delete bits of it, say I don't want that bit, or that bit there has actually already been highlighted, I'll do that. That bit's already been produced. If I want to move bits around, I can do so. This is all within the viewer window. The viewer window is completely independent of the data window. So once it's gone onto the viewer window, it doesn't affect the data window. What else can we do here? Well, there's other types of analyses one could do. One could look at the interaction between variables. One could say, okay, I want to look at the relationship here between the variable gender, let's say, and the variable employment category. Okay, so, and the good way to do that is to do crosstabs. So if I do put gender into the rows and employment category into the columns and click OK, it just produces this little table for me. This kind of a cross tabulation table for me. And that's fine. You can see that there are 0 female employees in the custodial group, and there are 156 males in the clerical group versus 207 females. There's 74 male managers and 10 female managers. We might want to have that as displayed as percentages. So if we went to call up crosstabs again, we could click on cells here and ask for what are called row percentages and click OK at that point. And now it says 94% of the females, because it's a row percentage, and gender is in the row, so it's 94% of females, hence percentage within sex employee, are clerical workers. Only 4.6% are managers. 60% of males are clerical workers, nearly 61%, 10% custodial workers, 28% managers. So a much larger proportion of males are managers than females. What happens if I just swap things around a bit? I can call this dialog up again. This is so useful about this little procedure here. And just swap that out and say, well, I'll just have that one and rerun it again. Let's look at minority classification. So now we have, of people who are ethnic minority group, 83% are clerical workers versus non-ethnic minority group, about 75%. 12% of minority workers are custodial. Only 3.8% of them are managers compared to 21.6% of the non-ethnic minorities, which are managers, nearly 22%. So we might be asking ourselves at this point whether or not these were simply random fluctuations, or whether there's a possibility that within the wider population of the bank employees, that in fact the non-ethnic minority groups do not have the same proportion of job categories as the ethnic minority groups. In other words, is there a statistically significant difference? And if we wanted to run a significance test of this particular type of analysis, the one that's most commonly associated with it is called chi-square. And we click on chi-square. We simply go back to the dialog box and we say, I want some additional output. I want to run a statistical test, chi-square. You can actually see there are many statistical tests one could run. Chi-square is the most common one that's used with crosstabs, but within a copy of SPSS, you'd expect to get over 200 different statistical tests, so it's quite a lot there. And I could ask it also to display clustered bar charts. Click OK. Here's the same output again. Here's our percentage table. Case processing summary just tells you how many missing cases you had. We didn't have any missing data here, really. How many valid cases, so it's kind of not that interesting to us. Interesting, though, you can actually suppress any output. If you don't want to show it, you can just double click on it. Over here, click on the little icon, so it looks like a closed book, and that output disappears. So see, I'm just double clicking on case processing summary. And here's my bar chart that I'm producing down here. It's interesting. It's producing a chi-square test for me, and the chi-square test has a resultant value which is less than 0.05 by some margin, and in fact less than 0.01. So what we're saying is, if we were interpreting that chi-square test, and our null hypothesis was that, minority classification in no way is related to people's job category, or vice versa. People's job category is no way related to people's minority classification, that the two variables are completely independent of each other. If that was our null hypothesis, then we would be saying that the probability of getting a result as extreme as the one we've observing in this table, assuming that the null hypothesis is true, and the universe where the null hypothesis is true, is actually less than 0.001. So it's actually less than 1%. And we would reject the null hypothesis based upon that. So that's how we'll be looking at that in more detail, of course, later on when we look at significance tests. But that's the principle behind it. What happens if I wanted to look at something like salary against job category, or salary against gender, or something like that? Well, you couldn't really do a crosstab in its current format with that. So I went to do crosstabs with that and hit reset. This is what it would look like. I mean, it would look crazy. If I put salary in the rows here, say against gender, and not even ask for things like row percentages, and click OK. It's just useless. The output's useless because salary is not a category variable. It's individual people's salaries. There's way too much detail in that. So what one would normally do is one would recategorize that or band it in some way. And it turns out there's a really nice way to do that in SPSS. You can go to transform and down to visual binning, this procedure here, visual binning. And if I pick up the variable salary and put that in there and click continue, and it shows me salary as a distribution here. So it's basically scanned the data. And a good tip is to go to make cut points and to click on the middle option here, which is equal percentiles based on scanned cases, and tell it how many cut points you want. So if I ask for 3 cut points, that's going to slice it into quarters, because 3 cut points slices it, tries to slice it evenly into quarters. And I hit apply at that point. It tells me where the thresholds are that's going to slice that. So that middle one there, 28,875. If I didn't like that, I could actually either change it here, or I could change it here. I can actually interact with this. And you can see that as I move that around, it actually updates it. See, look at that. So it's actually picking it up. But you can see that the cake isn't as sliced as evenly if I start to move that around a little bit. So we've got 37,050 here. So what I'll probably do is I'll just change that to, let's change that to just the 28,000. We'll just round it because it's a kind of a weird place to cut the data. And the same here for 37,050. Okay, it's not going to be absolutely equal. We don't need it to be equal. The reason why we're trying to get equal is just so that we have enough cases in each group to do a reasonable comparison. And then what I can do is I can say make some value labels for these thresholds that you're creating, because the thresholds are going to be denoted by 1, 2, 3, and 4. I make labels, it creates labels. And if I don't like the labels, I can edit those as well and just say this is less than or equal to 24,000. So let's say up to 24,000. And this is, that says 37,001 plus. Well, that's a bit of a weird way to put that. So I'll just say, change that to over $37,000. There we go. And then just give it this new field a name. We'll call it Sal Band. Oh, I've done that wrong. Sal Band. If I don't like the label here, I'm going to change this from binned, which is what's called, to grouped. There we go, Sal current salary grouped. And I'll click OK at that point. Clicks OK at that point. And there we have our new field that's been created. And it's basically been created from this variable here. If I right click on it and look at descriptive statistics, there it is. 25% are up to 24,000, 21%, 24,000, 28,000, 28%, 28,000, 37,000, and 25% over 37,000. So it's roughly equal. And it means, of course, that we can go back now and do other analyses like cross tabs and say, okay, let's look at, instead of current salary, we put current salary grouped in there and click OK at that point. And now we have a much easier way to kind of compare that. Normally, it doesn't really matter what percentage, what the direction of the percentage is in most cases. It depends on what you're asking, what you're trying to compare. So if I was trying to compare salary groups here, and I'm taking the row percentage, that makes sense. I'm saying that 88% or 87% of those people on over 20 up to 24,000 are female compared to 13% of males, whereas only 13% of those on over 37,000 are female compared to 86% of males. I could swap it around. I could actually say, well, look, you know what? I'm just going to move these guys around because I'd like to compare the two genders. I'd like to say what percentage of women are earning up to 24,000, and saying, well, 48% of women are earning up to 24,000, only 6% of men. 7% of women are earning over 37,000 compared to nearly 40% of men. So you would expect that to return a value to you in the statistical test. That is less than 0.05, in fact, less than 0.01. In fact, it's quite a lot less than 0.01. It's actually less than 0.0001. So again, the probability of getting a result as extreme as the one observed, assuming that in fact your current salary was in no way related to your gender, is sufficiently small that you would reject the null hypothesis that the two variables are completely unrelated to one another. Now, as more on the subject of creating these sorts of tabular outputs, you should be aware that we have this module called tables, custom tables. Click on custom tables here, and that's kind of like cross tabs, but it's cross tabs on steroids. Really, it allows you to have a great deal of control over what's in the tables. Most of the output we've looked at so far, it's kind of default output. You don't have a lot of control over the formatting or the appearance of the table. If you use the custom tables module, you have a lot more control. And for example, I could take the variable employment category here. I could place that in there, and I very intuitively then can put current salary across the top. If I put that up there into the columns, that goes in the top, and that's a little table now just with frequency counts in it. I could pick up minority and have that as a subset of that, or sorry, I'd have it as stacked on the end of that, or I could have it as what's called nested within that. So I can have or nested within this, so I can create more complex tables. So this way of interacting with the data. I could pick up things like education level in years and add that on to the end. So now I've got a mean or a median, and I could do the same thing with previous experience in months and add that on to the end. And then I could control things that if I click along here, I could control things like totals and where they appear, apply. I'll say I have a total there, and I'll put a little total here. And then I could control this and say, actually, these summary statistics here, I don't want the mean. I'd prefer to have the median. So I'll choose the median. So it gives me a lot more control. Hit apply to all. And then here I could say, well, look, I've got the count, but I really want the row percent as well. So you can see there's a ton of different percentages and controls. And I could control the title and give it an example title. You know, this is an example custom table. You could put titles in the caption in the corner, different test statistics. And you can even go in here to table style and say, okay, I want to highlight certain values based upon any, let's say anything which is a percentage above 20%, something like that, like that highlighted in yellow. And there's lots of different table formats to see. But if I click OK at that point, you can see this is the table that's produced. So it's much more, you know, it's a lot, it's got a lot more going on in it, and we can control it. If I double click on any sort of tabular output within SPSS, in fact, any tabular output, you can go to format here, table looks, and choose a different table look. And you can set these up by default. So there's one called blue, change that. And in fact, if I go to edit options and I said, you know what, I like that table look, I could go into edit options, pivot tables, and find this table just called this table look called blue and say, have that as my default from now on. And you can see that if I ask for a new table output, it just produces it in this new format. So there's lots of, and you can create your own table formats, and you can download some table formats that we have created from our website if you want to look at that in more detail. Okay, what about if we wanted to kind of filter out a group? Let's say we wanted to, for whatever reason, we want to do an analysis, but we're not really interested in the manager group. We're really interested in comparing, or let's say we're not really interested in the custodial group. There's only 27 of them in there. We're interested in clerical and manager. In fact, I think that the original court case was brought by clerical workers against management, so maybe that would be appropriate. So if I say, you know, I want to produce a data set, but I want to filter out these 27 cases. How do I do that? Well, if I go to data and down to select cases, there's different ways which I can do it, but one of the most common one is just to click on if condition is satisfied and say if this is true. So I'm going to say, if I said if employment category equals, and I can right click on fields in dialog boxes, very useful to know about, and look at variable information. So I can say if employment category equals clerical, that would be 1. Or employment category equals 3 for manager. Or alternatively, I could just say, look, if employment category is not equal to 2, because 2 is custodial. So that's the not equal sign. You can see it down here. So you can create quite complex sort of formula, but this is the most common sort of formula. If I click continue at that point, there are different ways in which it works. One is the default is to filter out unselected cases. Let's see what happens if I click OK on that. And if I just look down here, you can see that sometimes you'll get these little strokes appearing on the case headers, and that they're attached to not selected. So anytime it says not selected, it's a little stroke. That means it's a custodial worker. So wherever you see custodial worker, there'll always be a little stroke next to it. And that means it's not included. And we know it's not included in the analysis has been filtered out of the analysis, filtered out of the subsequent routines we run. It's because if I right click on this and ask for descriptive statistics, you can see it only shows clerical and manager. And if I went back here and I did crosstabs, and instead of saying current salary, sex employee, I put in employment category against current salary, you can see that it just includes clerical and manager. The other ones, they're actually gone. So they've gone from that group. So they haven't been included at that point. So I filtered them out. The other way to deal with it is to go to data, select cases, and you could create another little data set it's called managers. It's called MGMT and clerical. And that would create another little data set for you in the background. You click OK at that point. And in the background, there'd be another little data set labeled management and clerical. And so that way you kind of put them to one side. You right click on here and you can see that it would just have in the output, it would just show clerical managers. So there's different ways in which you can do that. Let me just shut that data set down, that additional data set called clerical manager down. I just need to hit close on that. And if I go back to select all of the data again, I go back to data, select cases, all cases. Also I'm doing saying select all cases. You'll see a little message here saying filter on. That will disappear. Click OK at that point. And we know we're back to selecting all cases because if I right click here and hit descriptive statistics, we're back to looking at all 475 cases, and the custodial workers are included in that as well. So lastly, let's just touch on things like charts, things like that. So you should be aware that with output in SPSS, you can actually double click on the output and you can manipulate it and play around with it. You can right click at it and say, okay, create charts from bits of that. So if you just want a little bar chart, go and create that. A little bar chart of employment category, showing percent, valid percent, all that sort of stuff. Or you can delete these bits if you don't want them in there. But alternatively, you can go to graphs and go to chart builder. And chart builder here starts giving you a little menu of charts that you can choose. So I'm going to choose, let's see what's an interesting fancy chart to choose. Let's go for scatter plot here. For a nice scatter plot here, and I'm going to pick that up, drag that across into the onto the canvas, if you like. And then I'm going to choose current salary against beginning salary, what people's beginning salary was against current salary. And I'm going to color that by their job category. And I'm going to make the size of the bubbles based on their education level. That seems to make sense. There you go. That's the size bubbles. Click on OK at that point. Is there anything else I can do here? Let's see. Chart appearance. I can change the colors of the chart appearance. I don't really, not terribly loving these colors here. So I might change that first category there to red, second category here to blue, and then the third category here to kind of like an orange color or something like that. It looks a bit better to me. There are other templates that one can choose up. You can use these other templates. And say I'll have bright, or I'll have legacy, I'll have pastels. Okay, let's go for pastels. Click OK at that point. That produces a little chart for you that you can interact with, and this is showing me that there's a very strong correlation between people's beginning salary and the current salary, and that it's true that those on the higher salaries do tend to have larger circles, so they do tend to be, they do look like they have more years of education, as one would expect. You can actually interact with this and say, I'm interested in who is that guy up there? You know, who is that person? And you can ask it to jump to that individual and see who they are. You can kind of identify who these people are, or you can create a little selection of that. So you can go to that case. It's this person here, case number 29, and their manager on $135,000, which, given that this is in the 1980s, is quite a lot of money at that point in time. So charts are important, of course. You create lots of different charts and graphs that one could create. One that I like to use, hit reset. And so if I'm representing 3 categorical variables in a table, that can be really quite complicated. So an easier way to do that is sometimes just to do a pie chart, but rather than doing a pie chart is to add what's called panels. You can add row panels and column panels to it. So if I do a pie chart here, and the pie chart is, let's say it's employment category. No, let's say it's one for our new variable here, which is a current salary categorized. I'll just put that into, slice by that. I think I've done this right. And then put gender across the top, and I'll put employment category down here in panel. Click OK. You can see it's actually creating a chart for every combination of female or male versus clerical, custodial, manager, showing where the salaries are. There's one that's missing here, of course, because there are no female custodial workers at that point. So it's interesting to know about that and to play around and to explore the charts. Probably the smartest thing you can do. The last thing I wanted to talk about really was this business of syntax. I've just done a whole series of videos on how to create syntax jobs. But the point about syntax is that if I look at these procedures I've run, like crosstabs and frequencies and things like that, if I hit the button mark paste here, it shows me syntax. Now this is somewhat confusing if people aren't aware of it. In version 29, you have a version of what's called Workbook Mode. I'm in Workbook Mode here. And syntax mode is kind of, I'm actually going to switch this, if I can, to another mode. I'm going to switch this and say this application is working. And switch it back to classic mode. I don't want to save that output. Yeah, classic is probably what you'll get, just to make it easier. So classic mode is when the syntax doesn't appear inside the output window. That's what workbook mode is. This is the classic mode. So if I go back here into frequencies and hit paste, what you can see is it opens up another window. Okay, and this is called a syntax editor window. The workbook mode is a new kind of innovation that they put in there for people who are used to working with things like Python and R. I should be able to go in here and change the fonts and things like that and make this a much larger font. Let's say, yeah, so it's much larger font there. So you can see that is the command that SPSS is running when I run a frequencies procedure. So I could hit run selection here, and it just runs that frequency procedure for me. So I could go back through my analysis. I could go back through it and say, yeah, paste that, add that to my syntax job, and look at adds it to it, and then go back to it and say, what else did we do? We did that chart builder thing there. Yeah, let's have that, but let's change it a wee bit. Let's have it then, instead of employment category, we'll have minority status, something like that in there. Put that in the panel and paste that, and we can build up a syntax job. And if this was a regular, data set that I was running, I was grabbing data from on a monthly or quarterly basis and doing the same sort of analysis. Of course, what I could do is I could build up my syntax job and then just format the data, add the new variables, create a filter, do crosstabs, frequencies, some significance testing, that sort of stuff. And then just every month I could just run it, and it just run the whole thing for me. And then if I wanted to export it, I could do so. I could go to File, Export, and I could export the output in lots of different formats. So I could export it in Word. I could export it as PowerPoint. PowerPoint's a pretty good one. I could export a PDF if I wanted, like that, and say, okay, I'll have that. And let's see if I can put this on desktop. Sorry, I'll just go test. Let's see if that works, and then go save, export. I haven't tested this. As version 29, so it's this latest version. Let's see. And if I then just minimize that, and just Alt Tab out to my desktop here somewhere. Sorry, I've got lots of controls in front of me. There we go. Is it there? There it is. Yeah, test.pdf. And just shows me that. It's showing me some of the hidden, what's called the notes, which are hidden, but you can delete those. You don't have to show them when you export an output. So let me just show you what that's referring to. And whenever you run an analysis in SPSS, you can see these little hidden boxes. These are the notes. that records when that and that output was created, who created it, whether there were any filters on it, what the syntax was. So it means it's auditable. You can audit all of your analysis output. And when you come to exporting your output, if you go to like output here and you go File, Export, you can see it says export all objects or all visible objects. So if these are double clicked and they've got a closed book symbol next to them, it means that they're hidden and they're closed. They're not visible. So you wouldn't export them. You wouldn't see those. Just to make that clear. Okay, so that's our tour through using IBM SPSS, in this case, IBM SPSS Statistics version 29. Just so you're aware that we've got a lot of additional resources on our website, lots of additional resources that we that we deal with, that we've got videos and blogs that just will support everything that you've talked about here. If you're starting your journey in SPSS, so you've got FAQs you can ask about. And that's it. Let me just check the Q&A here. So how do you get the percentage within minority classification within the table? Okay, percentage within minority classification comes up simply because if I go to crosstabs here and I choose employment category, that's in my rows, and I go to sales and I say I want the percentage of whatever's in the row, then it will be percentage within minority, within employment category, as we see here. I continue and OK. See, it says percentage within employment category. So it's just indicating whether it's a row or a column percent. Let me switch off this test. Whereas if I changed it and said in the sales here, I wanted my column percent, then it would say percentage within current salary, because current salary is in the column percent. So hopefully that makes that clear. Now it says percentage within current salary. So that is how that's brought about. Okay, if you're interested in finding out what other webinars we've got coming up, we have a long agenda of different webinars that we have coming up over the next few weeks. In the next webinar we're doing today, we're going to be looking at, I believe, data cleaning with IBM SPSS Statistics. So still on the SPSS Statistics theme, and I believe that's at 1 o'clock. We do look forward to you joining us for that. If in the meantime you have any questions, please feel free to drop us a line, drop us an email, and we'll do our best to follow up with you offline afterwards. Thanks very much.